So today you started taking a look at section 1.6, polynomial functions and their end behavior. So you guys did some categorizing here of different graphs, and the end behavior of a function describes how a function behaves as it moves to infinity to the left or right. So in other words, we're wondering what happens to f of x or y as x increases or decreases. So our notation, it's also called limit notation too. So the left is x goes to negative infinity. So limit stands for like limit. What does it end up with? So we're saying as x goes backwards, what happens to y? So as it decreases, what happens to the y value? In our right end behavior, we'll see we have the infinity here. So as it goes forward, what happens to our y value? So let's take a look at some of these, and we're going to see if we can describe them verbally. So this one, the left behavior verbally. So as x gets smaller, so as x goes this way, what happens to y? Y gets bigger. So our limit statement, as x gets smaller. So the limit as x goes to negative infinity, so as it gets smaller, of f of x, we were going to say that it goes to infinity here. As x gets smaller, y goes to infinity. Because you're saying as it gets bigger, f of x, our y value goes to infinity. So our right one, as x gets bigger, what would we say about y gets smaller? So again, that statement. So the limit as x goes to infinity, so the limit as x goes to infinity of y, we would say it goes to negative infinity. So let's see if we can do this one verbally. As x gets smaller, y gets bigger. So our limit as x goes to negative infinity, our y value goes to infinity. And then the right one, as x gets bigger, so as x goes this way, y gets bigger. So again, our limit statement. The limit as x goes to infinity of f of x. So as it gets bigger, our y value also goes to infinity. So let's take a look at a couple of these. So let's look at these with end behavior. As x gets smaller, so as it gets smaller, it goes down. So it's got to look like this. And this one, as x goes to infinity, it also gets smaller. So it could look something like this. Now, how about this one? As x gets smaller, our y value gets smaller. So it's got to end like this. And as x gets bigger, our y value gets bigger. Now, kind of to summarize what we talked about when you guys group these together, if we look at the degree of the polynomial, if it is odd degree, or if it is even degree, we said it either looks like this if it's odd, or like this. Even was something like this. And again, we said when we looked at your graph, these are just the ends. There's a lot of stuff that could be going on around here, but just on the ends of the behavior. So I'm just going to shade that in. It might not look anything like that, but it ends like one of these if it's odd. And then we could tell it ends positive if our leading coefficient is positive. it ended up this negative slope if the leading coefficient is negative. Even, it ended up up if the leading coefficient is positive, and down if the leading coefficient is negative. So when we take a look at this, we know that this is odd degree and it's even. So it's going to end like this. It's an odd degree, so it's a squiggle, and it's a positive out in front, so it goes up. So our left would go to negative infinity, our right to positive. Even degree and positive, so it's going to end up like that, so it's positive and positive. This is an even degree but negative, so negative infinity and negative infinity. Odd degree and negative, so the left is positive, the right is negative. Here's our highest power. It's odd and negative, so it's going to go down. So the right is negative infinity, the left is positive. And what would this one be? 1, 2, there's 3, but it would be negative. So this would be positive over here and then negative. So let's see if we can write some limit statements. So this is even and negative. So it looks like this. So the limit as x goes to infinity of f of x. And then what is the limit as x goes to negative infinity of f of x? Well, as it gets bigger, it goes down. So that's negative infinity. And this end is also going down. So they're both negative infinity. And then let's look at this one. Again, we have those limit statements. So what does this look like? It's odd and positive. So I know it looks like that. So as it gets bigger, it gets bigger. And if it goes negative, it goes down. And then we could graph some of these. But again, we could look at it and say, I know that this is a parabola. It's a even and positive. So as f of x is x, oops, I wrote this wrong, excuse me. So the limit is x goes to infinity of f of x. And the limit is x goes to negative infinity of f of x. Well, they're both positive, so they're both going to be going up. Now this one, it's not quite as easy, so we got to take a look at a graph of it. Well, if I graph this, we could see that it looks something like this. Oops, and right here. So the limit is x goes to infinity of f of x. And the limit is x goes to negative infinity of f of x. Well, what I notice is it levels off right here. It's not going higher or lower, so they both level off at about 2. And the same thing on this one. If I was to graph this one, it looks like this. So it levels off. It's not keeps going higher and higher. It kind of levels off there. So the limit is x goes to infinity of f of x. And the limit is x goes to negative infinity of f of x. It levels off at 0.